So let's have the solution to example 46 about an arc. The 3-pin arc is subjected to the set of load shown. Determine the component reactions at A, B, and C. So considering the whole system, let's put the component reactions at A and at C. And we can solve AY and CY directly. So we have to compute for the distance. This is R sine 60, half, another R sine 60. So this is R cosine of 60, so 0.5 R. This is R radius times sine of 60, so 0.5 R. This is also 0.5 R. This vertical distance is also 0.5 R. And this vertical distance is R, because this is radius and this is 30, so R cosine of 30. So AY, summation moment about C equals 0 clockwise positive. So AY times 2R sine 60 plus 15 and 15 times quantity R cosine 30 minus 0.5 R. Then equals 30 times R sine 60 minus 0.5 R, this horizontal distance, plus 30 times R sine 60, then plus 30 times quantity R sine 60 plus 0.5 R. So cancelling out R, or just imagine that R is 1, then we can now solve for AY. AY equals 38.66 kilonewtons. So summation forces Y equals 0, or summation moment about A 0. So because this is correct, so let's just use summation forces Y to solve for CY directly. So 38.66 plus CY equals 3 times 30. There are 30 kilonewton downward load, 30 kilonewton load. So CY equals 51.34 kilonewtons. Then let's draw the free body diagram of AB and BC. Let's put it here. Then the distance, remember, R sine 60. This is also R sine 60. Then the vertical distance, this vertical distance is R minus 0.5 R. So this vertical distance is 0.5 R. Then the vertical distance between the 15 kilonewton load and B is, because this is R and this is R cosine 30, so this is R minus R cosine 30, which is represented or indicated shown. And this is 0.5 R, as I said, radius from here to there, radius minus 0.5 R, so that's also 0.5 R. So considering AB, we sum up moment about B counterclockwise positive. So AX times 0.5 R, that's counterclockwise, plus 15 times quantity R minus R cosine 30, that's counterclockwise. Then plus 30 times 0.5 R, then equals clockwise moment 38.66 times R sine 60. So cancelling out again R, or imagining that R is 1, we can now solve for AX. AX equals 32.94 kilonewtons. So by the way, because the 30 kilonewton load is acting at the center of this hinge or pin, then we will distribute half to B just to the left and half B to the right. So that's why we have 15 and 15 here. Then considering BC, summation forces or summation moment about B equals 0. So we have Cx clockwise positive. So Cx times 0.5 R plus 30 times 0.5 R, then equals 15 times quantity R minus R cosine 30 plus 51.34 times R sine 30. So again, cancelling out R or treating R equal to 1, we can now solve for Cx. Cx is 62.94 kilonewton. So going back to the whole system, AX is 32.94 plus 30 is 62.94 minus Cx. 62.94, so that balances horizontally. Then finally for By, summation forces y equals 0. 51.34 equals By plus 15 plus 30. So By is equal to 6.34 kilonewtons. Because B is an internal pin, internal reaction, there's no need to indicate if it is upward or downward because that's an internal reaction. Then summation forces X, Bx plus 15 equals Cx, which is 62.94. So Bx is 47.94 kilonewtons. So that's it. This is the solution to this three pin arc or three hinge arc.